So now we are heading to question number 5.4. So 5.4, they say determine the general solution of the following equation. Our equation is given to be 2 sine of alpha multiplied by cos of alpha is equals to 2 cos squared alpha minus 2 sine squared alpha. Right? So at this point in time, they want us to determine the general solution for alpha. So this is for 7 marks, right? We are not given the interval. If we were given the interval, then this is where we're going to use the k, which is the element of integers. So this is just 7 marks. So the aim here, né? The aim is to make sure that we have only one trigonometric ratio. This could be tricky, but it's easy if I have to be honest with you, because looking at these sides of, I love how they place this question, by the way, because having a look at the left-hand side and the right-hand side, those are double angles. Look, 2 sine alpha cos alpha, that's a double angle. Cos squared alpha minus sine squared alpha, that's another double angle for cos, right? The only thing that you need to do is you need to factorize, you need to take 2 outside of the bracket. So let me rewrite it. This one, it is a double angle for sine. So you can change it to sine 2 alpha, right? Then here, take out 2 outside to avoid confusion. We have cos squared alpha minus sine squared alpha. And then this is a double angle for cos. So we have sine 2 alpha is equals to 2. The double angle over there is going to be cos 2 alpha. And then now what are we then going to do? Then we're going to divide both sides by cos, because remember, the aim is to make sure that we work with only one trigonometric ratio. It's either we work with sine only in the equation, or work with cos on the equation, or work with tan on the equation. By looking at this equation, we can see that if we decide to divide both sides by cos, this side we're going to have sine 2x, not x alpha, divided by cos 2 alpha. This side you're going to left with 2. So this is a quotient identity. We know this corresponds with tan 2 alpha is equals to 2. Now we have only one trig function. That was the aim. We wanted to make sure that in this equation, we end up with only one trigonometric ratio, right? Right. And from here, we can determine our reference angle. We're going to have 2 alpha is equals to second function of 2. Therefore, our reference angle in this case will be what? Don't divide by 2 as yet. Leave it as it is for now, because this is your reference angle. So at this point in time, second function of tan 2 to 2 decimal places. Definitely we're supposed to get, but again, 63.43 degrees plus 180, because it's tan, we use 180 times k, whereby k is the element of integers. So from here, then we're going to ask ourselves, we're going to take it from here. We're going to ask ourselves, the tan function, where is the tan function positive? From your Cartesian plane, you know that your tan function is positive in the first quadrant. It is also positive in the third quadrant. So first quadrant, we're not gonna take it. We're gonna take it from here, from the reference angle. But for now, we're gonna only focus in the third quadrant. In the third quadrant, what's happening? It is 180 degrees plus in the third quadrant. It is 180 degrees plus. So now we're going to substitute our reference angle. So on this side, making use of this reference angle, on this side we have 2 alpha. On this side we have 63.43 degrees plus 180 multiplied by k, whereby k it is the element of all integers, right? And then now what we're going to do, we still do have our 2 alpha this side, and then we're going to have 180 plus 63 point whatnot, plus 63.43 on my calculator. I get breaking 243.43 degrees plus 180 times k. I don't need this thing anymore. K is the element of blah blah. I've already mentioned it from the first step. And then now, because I'm looking for alpha, not 2 alpha, I'm going to now divide both sides by 2. When I divide both sides by 2, let me see how much do I get on my calculator. That divided by 2, I get 121.715 degrees. Plus, remember, even 180, I'm going to have to divide it by 2. I'm going to have 90k. So this is the first solution. The second solution, I'm going to take it from the reference angle. This is when now I can divide by 2 after solving everything in the quadrants, okay? So from reference angle, what I'm going to do is I have this, I'm going to divide that by 2, everything by 2, 63.43 divided by 2, 63.43 divided by 2. My answer is 31.715 degrees plus 180 divided by 2, that will be 90k. Therefore, these will then be my two general solutions. So we were going to use a table only if we were given the interval over here. But at this point in time, we are not given the interval. Therefore, our solution will just look exactly like this one over here. Okay, so this is how we solve this question.